Alright, welcome to fractions. This video is for grade 7, 8 and 9. We're going to look at adding fractions, subtracting fractions, multiplying fractions, and for the grade 9s we'll also look at the division of fractions. Okay, starting with the definition. The top part of a fraction is called the numerator and the bottom part of the fraction is called the denominator. Now, if the top part, the numerator, is smaller than the denominator, this is good. So it's proper. We say this is how we want the fractions to be. It's a proper fraction when the smaller number is on top and the bigger number is at the bottom. But then, of course, the opposite of that, when you have the numerator, the bigger number, on top and the denominator is smaller, then that fraction is not proper. It's improper. And a mixed fraction is when we have a whole number mixed with a fraction. So let's put this to practice. So for question 1, you're being asked to convert the improper fraction. We know that this is improper because the bigger number is on top. So how do you then convert an improper fraction into a mixed fraction? Alright, we ask ourselves, how many times can 15 go into 100? So let's list the multiples of 15. It's 15. Excuse me. The multiples of 15 are 15, 30, 45. We keep adding 15, 60, 75, 90. We have to stop at 90 because if we add another 15, it will take us to 105. So we stop at 90. So how many times could 15 go into 100? Let's see. 1, 2, 3, 4, 5, 6 times. So 15 can go into 100 6 times. And from 90 to 100, the remainder is 10. Of course, we need to put that over that 15 there. Okay, so we've got a whole number of 6, and we can simplify the fraction part because 5 can go into 10 and into 15. So 5 goes into 10 twice, and 5 goes into 15 3 times. That is our solution. Of course, you should also be able to convert a mixed fraction back to an improper fraction, and that's very easy. The way to do that is that we add, we multiply that way. So 6 times 5 will give us an answer, and that answer we add to 4. So let's look at that. So 5 times 6 is 30, and 30 plus 4 is 34 over 5. Alright, question 2, adding or subtracting fractions. Of course, in order for you to be able to add or subtract fractions, the denominators need to be the same. If the denominators are not the same, then you have to make them be the same. But for 2.1, it's very easy because all the denominators are the same. So we can just add or subtract. Alright, we've got the denominator of 7. So let's add the numerators. 3 plus 6 is 9. And 9 minus 2 is 7. Of course, 7 over 7 is 1. Okay, let's move on to 2.2. And of course, whenever we have a mixed fraction, we want to change that fraction and make it improper. Alright, so we've got 3 over 13. And let's convert that mixed fraction. 13 times 3 is 39. So 13 times 3 is 39. And 39 plus 2 is 41 over 13. And of course, the denominators are the same, so no problems there. We've got a denominator of 13, and we can just add the fractions, the numerators. 3 plus 41 is 44. Of course, we cannot leave our answer as an improper fraction. We need to convert it and into a mixed fraction. So how many times could 13 go into 44? Let's check. The multiples of 13, 13. Add another 13, you get 26. Add another 13 to 26, you're going to get 39. All right, you cannot add further because that will take you past 44. All right, so we stop at 39. So 13 can go into 44 1, 2, 3 times. All right, and from 39 to 44, the remainder will be 5. All right, over, again, remember it's going to be over that 13. That is the solution. All right, for 2.3, slightly complicated because now the denominators, as you can see, are not the same, right? We've got 6 and we've got 7. And of course, we cannot add a fraction or subtract a fraction if the denominators are not the same. So, as a rule, if the denominators are not the same, as it is the case here, we have to get them to be the same. And the way to do that is we can multiply this fraction by the other's denominator. So we multiply this fraction by the 7. All right, and we multiply this fraction by 6. So you multiply each fraction by the other fraction's denominator. All right, that way we can get the denominators to be the same. Okay, and of course 5 times 7 is 35. And 6 times 7 is 42. 3 times 6 is 18. And 7 times 6 is 42. And of course 35 minus 18. We've got the denominator of 42, so no problem. So 35 minus 18 to get the numerator. 7. Alright, so that's 17. 17 over 42 is our solution. Now we move on to 2.4. Alright, for 2.4, we're given 3 times now. Alright, and the first thing we want to do is we want to change the last term into an improper fraction. Remember, we always have to change the mixed fraction into an improper fraction. So we've got 3 times 2, which is 6, and 6 plus 1 will give us 7 over 3. And again, we have the similar problem we had in the previous question. The denominators are not the same. So what can we do if the denominators are not the same? We have to make them be the same, okay? All right, so we can start with the first two. Let's start with those two. All right, so if we look at the first two terms, all right, we want to get the denominators to be the same for the first two terms. So what do? We multiply that fraction by the other fraction's denominator. And of course, we also multiply this fraction by the other's denominator. And we can solve this. 3 times 2 is 6. And 5 times 2 is 10. 1 times 5 is 5. 2 times 5 is again 10. And of course, we still have 7 over 3 at the end. And as you can see now, the denominators are the same. So now we can simplify. 6 minus 5 is 1 over 10. Okay, plus of course that's 7 over 3. And then we apply the same method. We want the denominators to be the same, so we multiply this fraction by the other fraction's denominator, which is 3. We multiply this fraction by the other fraction's denominator, which is 10. Okay, so if we multiply that out, 1 times 3 is 3, 10 times 3 is 30, 7 times 10 is 70, and 3 times 10 is, of course, 30. And as you can see, now the denominators are the same. We've got a common denominator of 30. So that means we can add the numerators. 3 plus 70 is going to give you 73. Of course, this is improper because the bigger number is on top, so we can't leave our answer like that. So let's check how many times could 30 go into 73. Only twice, right? The multiples of 30 are 30 to 60. We cannot add another 30 because that's going to take us beyond 73. So 30 can go into 73 twice, leaving a remainder. Remember, from 60 to 73, the remainder will be 13 over that 30. And of course, that is our solution. All right, so let's move on to the next question. The next question deals with the multiplication of fractions. Multiplication of fractions is really, really easy because for multiplication of fractions, we don't care that the denominators are not the same. Remember, that's only one term. So we could just multiply it out. Only positive and plus and minus can separate terms. Multiplication does not separate terms. So just multiply it out because it's only one term. Alright, so 3 times 6 is 18 and 5 times 7 is 35. Okay, so that's it. Let's move on to 3.2. Alright, for 3.2 we've got a bracket that we must get rid of. 3 times 1 is 3, 4 times 2 is 8. Alright, we want to again convert the mixed fraction into an improper fraction. 2 times 2 is 4, and 4 plus 2 is 6. So we've got 6 over 2 and negative 3 over 4. Okay, so to work this out, we can just multiply through. Remember, we don't even look at the denominators for multiplication, we just multiply. 3 times 2, 6 is 18, and 18 times 3 is 54. Okay, 8 times 3 is 24, and 3 times 1 is 3, 3 plus 2 is 5. So the numerator part will be 54. 8 times 2 is 16, right? 8 times 2 is 16, and 16 times 4. 6 times 4 is 24, and 4 times 1 is 4, plus 2 is 6. So 64. And of course, 2 can go into both numbers. So when we simplify, we ask how many times can 2 go into 54? 2 can go into 54 27 times. 2 can go into 64 32 times, and that is our solution. All right, let's move on to the next question, comparing fractions. All right, which fraction is bigger? Would it be 2 over 3 or 3 over 4? And if we have to compare fractions again, we want those fractions to have the same denominator. That's the only way we can compare them. So 2 over 3 compared with 3 over 4, and we want to check which fraction is bigger. And of course, just multiply the one fraction by the other's denominator. So we multiply 2 over 3 by that denominator, and we multiply 3 over 4 by the other fraction's denominator, so that we can get the denominators to be the same. 2 times 4 is 8, and 3 times 4 is 12. So that fraction will give us 8 over 12. 3 times 3 is 9, and of course 4 times 3 is also 12. So that's what we get from that fraction, 9 over 12. And it's easy to see that this side is bigger. 3 over 4 is bigger than 2 over 3, because when we when we make the denominators the same, we get 9 over 12, is 2 over 3 will give us 8 over 12. So 3 over 4 is bigger. Okay, so in the exam, you might also be asked to arrange the values in ascending order. And of course, if you have to do this, it'll be easier if you write all the fractions as a percentage. And of course, writing as a fraction as a percentage means that you need to multiply it by 100. Okay, starting with the first one. If we multiply it by 100, it will give us 60%. So 3 over 5 multiplied by will give us 60%. So that one gives us 60%. This one, you take 6 over 7. If you multiply it by 100, it will give you 85.7%. And the final fraction, 4 over 6, if you multiply that by 100, it will give you 66.7. So once you've multiplied all the fractions by 100, we can now compare the fractions. So ascending order means we must write them from the smallest to biggest. Okay, so obviously the one with 60% is the smaller fraction, followed by 66.7, and the biggest fraction would be 6 over 7. So to compare fractions, just convert them to percentages, multiply them by 100, and then it will be easier to compare and check which is bigger than which. Alright, this is where we say goodbye to our grade 7 and 8s. The next section is for grade 9s only. Alright, the division of fractions is for grade 9s, and very, very easy. All right, and when we deal with division of fractions, we just have to remember that division and multiplication are inverses. Okay, so let's look into that. And of course, the first thing that we want to do is we want to change the mixed fraction. So we say 4 times 2 is 8, and 8 plus 3 is 11 over 4. All right. So now, once we have converted the mixed fraction, we can now change the division into a multiplication, because division and multiplication are inverses. So if you change the division to a multiplication, the last fraction will also become an inverse. And of course, 11 over 4 will flip and it will become 4 over 11. So let's repeat. If you change the division into a multiplication, then you must also flip the fraction at the end. Now 3 times 4 is 12, 5 times 11 is 55. That is our solution. The last question. Okay, we've got a fraction over a denominator made up by 2 fractions, okay? So what we want to do here is we want to write this as a division problem. So we'll write that as a division problem, and the part in the denominator, we will write it inside the brackets. Okay. And of course, before doing anything, we want to sort out this bracket. Okay, we've got negative 2 over 5 divided by. All right, remember what we want to do. Because the denominators are not the same, we cannot add. So we have to make them be the same, and we know how to do that. We multiply this fraction by the other's denominator, and we multiply this fraction by the other's denominator, which would give us 3 times 1, which is negative 3, and 2 times 3 is 6, 2 times 2 is 4, 3 times 2 is of course 6. Alright, now that the denominators are the same, we will be able to add those fractions. So negative 3 plus 4 is 1 over 6. Alright, and once we get to the point, we can once again change the division to a multiplication. So we've got negative 2 over 5 multiplied. Remember, if you change the division to a multiplication, the fraction at the end will also become an inverse. So 1 over 6 becomes 6 over 1. Right, so negative 2 multiplied by 6 will give you negative 12. And 5 times 1 will give you 5. To simplify, 5 goes into 12 twice. Alright, 5, 10. So 5 can go into 12 twice. Then from 10 to 12, the remainder will be 2 over that 5. And that is our final solution.